All right, today we're looking at lesson 54. We're looking at polar coordinates, and then we're going to look at similar triangles. Yes. This is new. You've never done this before. There are two methods to locating a point on a coordinate plane. What is a coordinate plane?
A grid, basically.
A grid. How do you normally locate a point? Like they tell you 3, -2, right? So you go over 3 and down 2. Okay. There's another way that you can write that. Those are called rectangular coordinates. The point that this is talking about is 5, -2. Hello. Yes, it is out. I don't know what's wrong with it. On both. Yes, really. And I had wireless internet working Monday on that computer, and then like it stopped working Tuesday. Like it wasn't working Tuesday. I don't know. Do what? Well, I can't take attendance, and I've been getting in trouble because I haven't been putting in attendance, and I'm like, I can't. My internet doesn't work, so. No, I can't. But I haven't had any. I haven't had any grades yet. The R, you can think of it as like right or left, like going this way, and then the U, up. So if you are going negatively up, you're not going up, you're going down. Does that make sense? Like if you're going up, like if you went up, it'd be a positive number. But if you're going up, but it's actually a negative number, then you're just going to be going down. But, I mean, that's how I remember the R and the U, what those mean, right? Or an up. Okay? So what would that look like? -3R and then -2U.
R is basically X.
Yes. Does that make sense?
Is it always going to be R and U?
Yeah, always R. Well, for algebra 2, yeah. Yeah. Any questions on just? No. It's just -3R -2U. That's just a different way to write it. Does that make sense? Okay. So R represents right, -R, going the opposite of right is left. U represents up, and -U represents the opposite of up, which is down. Does that make sense? Just write it down. This is the other method. The book actually has the 57 like all the way inside this little symbol. I actually do not know the name of the little symbol. You read that example 4 at 57 degrees. No, it is not an angle sign. It is an angle, but it's not an angle sign. I don't know the name of it. The book doesn't ever, like, they never tell you what the name of it is, but you read it 4 at 57 degrees. So what it means, the first number tells you how far away you are from the origin. So if I'm at the origin, but I want to be 4 units away, there are a lot of different points that are 4 units away, right? It actually makes the circle. Those are all 4 units away, right? But there is only one that is 57 degrees. You start from the positive x side, and you just go up 57 degrees. That says 57. They're all the same distance away, but it's a different angle. Yeah, it's a full circle. So if I wanted to go, instead of 57, if I wanted to go to 90 degrees, well, starting here, I hit 90 degrees right here. So that's the right angle. And so that point would be 4 at 90 degrees. Yeah, that point is 4 away, and it's 57 degrees away from the x-axis. Yeah, you always start on the positive x side. Well, you don't actually, you're not gonna have to draw them. You like exactly. It's just an estimate. Yes. You won't be using those, but yeah, I mean it'd be like measuring the angle.
Is that the clockwise?
No, counterclockwise. So I start here and go up. You always start over here and you go that way. The second number represents the angle of direction. You measure it counterclockwise from the positive x-axis. Yeah. So you would start, if you wanted to do it 300 degrees, well, this is 90. What is this angle? And that's, so 300 somewhere over there. Well, that's my point. And does that make sense? You're not going to have to draw these like to scale or anything like that. When you draw these, they're really just for your help. Do it. You just got to learn first how to manipulate them, and we'll get to how to use them later. Actually, not even in Algebra 2, pre-cal. So we're actually going to figure out where that point is. We did that earlier on the last slide. We just kind of drew it. Does that actually look like a 57-degree angle? Maybe, maybe not. Does it really matter if it's exact? You just want it close, okay? Yeah, this distance from here to here is 4. So what you want to do is figure out like how far over and up you had to go to get to that point. So you draw in a right triangle. Because that's the length of the hypotenuse.
Like, in inches?
It's just units. This is my R or my U?
Your R.
And this is my U. Does that make sense? You don't know the R. Okay, so how can we figure out the R and the U? Any ideas? Sine, cosine, and tangent. So for R, would you use sine or cosine or tangent? Okay, cosine of 57 degrees would be what? So what would R equal? Okay, figure out what that decimal is. Round to the hundredths place on these. It never actually tells you to round, but that's where you want to round. What do y'all get? 2.18. Any questions on how to get that? Okay, how are we going to find the u? Okay, sine of 57 would be what? And what do you get for u? If it was 4 over u, you would multiply both sides by u. You get u sine 57 equals 4. And then how do you solve for u? Divide by sine of 57. 4 and then divided by sine of 57 instead of 4 times. Yeah, yours is different. Yeah, does that make sense? Okay. Any questions on the r and the u? Okay, so the way that we actually write our answer, 2.18r, is that a positive or a negative u? Plus 3.35 u. Does that make sense? That's what it means. Sometimes it'll ask you, it'll say change it into polar coordinates or change it into rectangular coordinates. If it says change it, this is rectangular and that's polar. But if it gives you that and it says to change it, it means to change it into the r and u. Yeah, you go from that to that. We're going to go backwards. I think we have an example of that. Whenever you plot polar pairs, you're always going to draw your vector out to your point. It's actually a vector, the 4 at 57 degrees. It's not just a line, it's a vector. If you take physics, you'll deal a lot with vectors in maybe the second or third 6 weeks.
Do I have to take physics? You don't have to.
No, you don't have to. But you deal with vectors a lot in physics for like a chapter or something. Any? No, it's not physical science. Any questions on this? Okay. So your trig functions are going to be used to convert from one to the other. Sine, cosine, tangent to convert from polar to rectangular and from rectangular to polar. Tomorrow. Okay. $50. 350. Okay, these are the steps that we just did. If you want to write them down, if you need the steps. Yeah, this is step 1. You begin by plotting the point and drawing the vector. Step 2 would be use sine and cosine to find your r and your u. And then step 3, you just write it in rectangular form. Does that make sense? Okay. So see if you can first off plot the point and draw the vector by yourself.
We just draw the top right coordinate.
If it's in the top right coordinate,
It won't always.
it won't always be in the, yeah, it won't always be in the top right coordinate.
Oh wait, how will you know it is?
The angle will tell you what coordinate it'll be in.
Okay, so the first one is not.
You draw a coordinate.
We just that's like what the add-on is.
Yeah, it doesn't really matter.
I don't know which one. It's gonna be the third. Yes.
Yeah. 1, 2, 3. First, you want to figure out where 230 degrees is. You start here. Where am I now? And now, do I need to go all the way to this line? Because that's 270. So I come over here somewhere. If this is 180, how far did I just go? 50 degrees? Does that make sense? If this is 180 and I went out 230, the difference between that is 50 degrees. Does that make sense? Okay. So I just say, there's my point, and the hypotenuse is 7. You just make it however long you want it to be. Does that make sense? How to draw it? Okay. Where is my R? And then where is my U? Okay. So how am I going to find my R? Okay. The cosine of 50 degrees. So what is R? So figure out what that is. .499, which rounds to 4.5. Does that make sense? Any questions with that one? Okay. How would you find U? Sine of 50 would be what? So U equals R equals 4, well, yeah, when you write it, it's 4.5 R. Yeah, you always go left to right first. Do you see how to get the R's and the U's? Like what those values are going to be? Any questions on that part? Okay, so is this a positive or a negative number? Why is it negative? Yeah, because you went to the left. Just like your X value is negative to get over here, your R value has to be a negative. And so what? Negative 5.36 U.
So basically, if it's in the first specific quadrant, it's positive, and this is the third negative.
Because your X is negative, but then your Y is positive. And your X is positive, and then your Y is negative. Any questions on this one? Yeah, this one's negative. To go this way, it'd be, whoop. You'd have a positive R, positive U, negative R, positive U, negative R, negative U, positive R, and negative U. Just like your X and Y values. Any questions on that? Okay.
These aren't that.
I guess we're not going from rectangular to...
You mean polar to rectangular?
No, this is polar to rectangular. I guess we're not going backwards on this lesson.
Good. What do you mean?
I thought we were. They'll give you, like, they'll give you that, and you have to get to that. I guess we'll do that another lesson. Yeah. So see if you can draw 42 at 340 degrees. Try and draw it by yourself. Yeah, it's easy. It's on similar triangles. Again.
Similar triangles. Good. I'm not good
Like,
like the ones that are like a little different. They're like, you know. I can do some really from my regular time. I speak now.
somebody want to go draw the vector? Okay, go ahead, Scott.
This bottom one is 270.
Yes.
Wait a second. Ooh, I did it wrong. But you'd be fine and it's. Wait, I thought you had a triangle as well.
You do. Did he put the vector in the right spot though?
I thought you thought, yeah.
Close enough, right? You want to use this as your triangle. Always go up to the x-axis. You would, right? You wouldn't be using 70. What would you be using instead? Does that make sense? Do you see how that works? Any questions on that? Okay, so see if you can find your R and your U correctly. They're going to be bigger numbers.
So you're always use cosine and sine.
Not for these. When you go the other way, you'll use tangent. When you go from rectangular to polar.
No. If you use 70 triangle, would you
It'll be more difficult later.
I'm saying no word mess up on that.
Yeah. No, it would still work. Okay, what would you get for your R? And what do you get for your U? Oh, yeah. Yeah.
My little thing looks like it's drawn.
Do what? Do y'all get those two for your R and your U? So what would you write for your final answer? Does that make sense? Any questions on these? Sine and cosine are off by 90 degrees. So, yeah.
Like, is there an equation in real life where you get that by yourself without a calculator?
No, you have to have a sine, cosine, tangent table. A sine, cosine, or tangent table. Yeah, but like they'll say like cosine of 50 is this decimal, like whatever it is. But I don't know how you get those numbers. So
How do they know it's right?
they did it a long time ago.
I wonder how you program a calculator to do all these different ones. Yeah, calculator on like a thing. I did not want. I couldn't imagine being Dusty. Like I don't even. Like I can't even fathom
Yeah,
being.
I don't
Is he
know.
actually like autistic to be that smart?
No.
What does autism have to do with you? You're like really smart.
Yeah. Well, there are forms of autism that are really, and then there are forms of autism where like people are very, very slow. Like it's a extreme.
Yeah.
Like Asperger's is like on the high functioning autism, very, very smart. And I can't think of what's on the other end. Rain Man?
The guy where he's like always he like goes in after school and
That dude.
yeah.
And he has a little mouse.
Radio.
No.
The radio. It's Algebra or whatever.
I don't know.
Algebra. Yeah. That's what I was trying to say.
I want to be a head
All right, so let's look at these. The two triangles are similar. How do you know that they're similar?
Because they look alike.
No.
They have the same angle.
Which ones?
Oh, because they have the intersecting points, you know.
Okay, what do we know about these two angles? Okay, so that gives us one set of angles that are the same.
And then we know.
They mark these two. So do the third sets have to be similar? I mean congruent? So then the triangles have to be similar. Does that make sense?
Yep.
So how can we write a proportion about A, B, C, and D? A over D or B?
A over B.
Oh, wait, no,
A over B.
no, wait.
C over D.
C is across from the one angle that they gave us, right? Is D across from the angle that they gave us? So that's how we know that C and D go together. Does that make sense? If they ask you to solve this for B, what would you do? B is in boy. Does that make sense? That's what they're going to do on these kinds of problems. They'll give you just random letters, and then they'll say, solve for A in terms of the rest of them. What it means is A equals what? Does that make sense? Just without numbers, basically. Yeah, but now put them in triangles. Any questions on those?